Great, welcome. Welcome to the track Better Pixels, and thank you for joining. My name is Sally Hattori from 20th Century Fox. I'm one of the co-chairs for this track, and we also have Dr. David Long as my co-chair partner who will be chairing the sessions later today. As we see more and more adoption of UHD, HDR, high frame rate, wide color gamut contents in the market, it is becoming more important for us to understand the implication of these enhanced pixels to our creativity and ultimately how we perceive emotionally. We also see continuous needs in developing the ecosystem for these enhanced pixels. Technologies in production, distribution, and image processing to build this pipeline are evolving to reach the ultimate goal of better pixels for all of us, from the creatives to the end users. We will be introducing the studies in various parts of this pipeline as contributions to this continuous effort in building and evolving the ecosystem for better pixels. We have a total of 3 sessions in our track, and then this is the first session. The remaining 2 sessions will be after the lunch break here in the same room. Our first session is about HDR image analysis for effective storytelling. In this session, you'll be introduced to 3 studies on analysis of various HDR and SDR images to understand the semantics of creative intent through the statistics of the image and how we can apply those to produce a new image, keeping the creative intent. Our first speaker is Mr. Pierre Routhier from Digital Troublemaker, an author and specialist in advanced imaging technologies. He has developed innovative solutions and workflows for studios and post-production facilities in all fields of advanced imaging. He will be presenting what are the killer apps for HDR, analysis for SDR assets to predict the potential of HDR. You will hear about his interesting views on what determines the quality of HDR images and results from the statistics analysis based on those attributes for various types of content. Please welcome Mr. Routhier.
Thank you very much. Thank you, Sally. So it's fitting that I'm breaking the ice here with the first presentation. As engineers, we're typically handed down content, and then we have to manage through the production, distribution, and display, and manage the creative intent. This one is a little bit upfront of that. It's working with the creatives on actually creating new content that will give us exciting HDR experiences. So I've taken this from a 2015 presentation because I thought it was very well illustrating the idea of high dynamic range. Basically, the idea is to manage the OOTF, or the optical transfer function. Basically, we have photons, we have light in front of our camera, and the whole idea is to minimize the reduction of photons from what's in front of the camera to what's in front of your eyes when you watch the display, and managing that luminance. So we see that with HDR, we're dramatically increasing our capability. Surprisingly, that can be advantageous. That's not surprising. It can have little impact, or it can actually be detrimental to our experience, and that's what I want to talk about a little bit this morning when we're creating new HDR content. So analyzing tons and tons and tons of content, I came up with 4 different attributes of what should be a high-quality HDR image. Quality control is a bit of my past. I developed a quality control system when I was a Technicolor for 3D. In HDR, I came up with 4 types of attributes that determine what is a high-quality image from an HDR standpoint. So not necessarily creatively, but from an HDR standpoint. And they are latitude, richness, resolution, and composition, and I'll explain them a little bit here. Latitude is what we think of when we hear about HDR. It's the brightest highlights that I can display on the screen and the darkest elements that are still viewable to the human eye. What you see here is a high dynamic versus low dynamic type of image. So on the left-hand side, something I took this summer, during bright daylight, the sun is hitting the buildings, so we're close to the tipping point. We have very bright highlights, we have very dark shadows at the same time, so we have a lot of latitude in our image. One I took in the wintertime during a snowstorm, of course, the diffusion from the snow particles and the grayed out sky means that our darks are pretty gray and our whites are pretty gray as well. We don't have a lot of latitude, and that's typically our understanding of HDR. What I found out analyzing content is this is not enough to qualify HDR content. As you can see here on those two images, they both have very high latitude. Both have highlights at about the same level and dark levels at about the same level. But the one on the left has a lot of richness to it. We have a wide distribution of pixels from very bright to very dark, so it's quite attractive to watch it and appreciate all of those different levels. Where the one on the right-hand side, which is taken just before the sun sets, has very bright highlights, it has dark shadows, but there's not much in between, so it's not a very rich image. So that's the second attribute. The third one is resolution. So we have bright highlights, we have dark shadows. You also want to make sure that your pixels, especially on the highlight side, are not clipped. And that's the difference you see on those two images here, where the snow on the high resolution is bright, but I can also perceive details. Where this one here, for production and camera reasons, doesn't have the same level of resolution. You see that the snow is basically clipped and you don't perceive details anymore. So it's important to keep our images within the boundaries of what we can display. If we go beyond, this is where we lose resolution in dynamic range language. Finally, the composition. We have bright highlights, we have dark shadows, we have a good distribution, but is the light actually helping us with our subject of interest, or are we taking creative freedoms that distract us from what we should be looking at? So the one on the left-hand side, the timing is just right, the sun is just in the right position, and you can see where the lights and shadows are creating volume on the character. So that's a nice composition for HDR lighting-wise. The one on the right-hand side has highlights, shadows, nothing's clipped, but if I put this on a home display at 1000 nits, my eye is going to be drawn to the bright area, and I'm not going to perceive what's in the dark area, which, if that's what I want to show people waiting for the train, then it's not a composition that's very effective in HDR. So taking those four attributes, I looked at different tools that we can use to assess this kind of quality in our HDR images. And the two tools that I found most suited were the histogram, distribution of light in the image, and the good old analysis of exposure values, so go out and actually measure exposure. You can do this when you're creating new content, but I also found a way to reverse engineer SDR content to predict what it would have been, what the exposure would have been in HDR, and I'll talk a bit about that. So first of all, the histogram. If you're not familiar with the tool, it doesn't tell you where the pixels are in the image, but it's just a statistical representation of the different levels of luminance in your image and how many pixels are at which light level. So if we look at this histogram here, from the darkest to the brightest, we see that we have a lot of pixels in the dark area, so that could be a limitation in resolution. But the main thing is that we see pixels at all the different levels. So you've got a lot of richness in an image that has pixels at all levels. And then, as you see, the percentage on the vertical axis. If we have an image that has lower dynamic range in the source, then you will see unused pixels on the dark or the bright areas. And that can be an issue sometimes if our goal is to take content as provided to us and display it in HDR, and our container, if you want, of light is like this, but the image that is provided is like this. You're not going to make it tremendously spectacular on an HDR screen because it does not have this type of latitude from the way it was captured. A lot of shots I also see, this is the one that we saw when the sun was setting in the city earlier on, is we have highlights, we have dark areas, but there's not much in between. So the image suffers in richness. So yes, the highlights are going to be bright, you're going to see detail in the shadow, but since there's nothing in between, it doesn't make it a very spectacular or appealing image in HDR. This is an image that suffers from resolution issues. So you see that there's so many pixels that are clipped and at the dark level that it's actually going beyond what the histogram is showing. So a vast majority of our pixels are outside the boundaries. So it will still display on your screen, but those very bright highlights will have no details. So it doesn't make it a very flattering image in HDR. This is something we can do in SDR, let it blow over and smoothly clip. In HDR, with 1,000 nits on a home screen, it becomes very noticeable. So this is very useful histogram for the 3 first attributes. The 4th one, which is composition, I came up with a method to analyze exposure on SDR content to predict the value in HDR. So what I've done is I've taken, there's roughly 10 stops of exposure in SDR spread out, quantized over 8-bit. So what I've done is I've created a good old traditional exposure tool from the photography days and created 10 perceptually equal spaces between white and black and just read the Rec. 709 code values. This gives us a rough estimation of how many stops of exposure we have above and below our baseline in our images. I say rough estimation because someone can still be doing a lot of shading operations, so there's way to trick what's in front, but it's still a very good estimation tool when we run Rec. 709 material to determine where the highlights are, where the shadows are, and how much latitude we have in the image. So taking that in hand, I've analyzed a lot of stuff. What I'm going to show you here are just examples. They're just images I've taken off YouTube just to give you an idea. They're not the actual assets, as this is proprietary to the different clients. So just taking public images just to give you an idea of what happens with certain types of content when you put it in HDR. So the first things I've looked at is our conventional TV shows, so sitcoms, reality shows, talk shows. These are typically lit for very low latitude cameras historically. We don't create shadow areas. We have bilateral lighting. They're fairly flat, which was a need back then because of the camera's poor latitude, but the look has stayed on. So for those shows and the tests we've done, basically shooting it with an SDR or an HDR camera, put it on the same monitor, and we don't see much of a difference. That's an example from a talk show in Montreal. And what you can see on top with the histogram is the distribution of light is pretty narrow. So you have less than 7 stops in front of the camera. So even if my display has 12 or 14 or more stops of latitude, if I don't have this latitude up front, I'm going to have a very big container of HDR, and I'm just going to use a small fraction of it. So I'm not going to be amazed when I put the image on the screen. For sporting events, it varies greatly, and this is where if you are involved in sports, I think it's very important to do a lot of analysis beforehand to select the right type of sporting event that will give you the most benefit from HDR. There's 2 major families of sporting events that I find for HDR. The ones that are done either indoor or outdoor at night, basically events with artificial lighting. The other type of event is daylight, which you don't control where the sun is going to be, the shadows, the clouds, and everything else, which tends to be a lot more variable. So the indoors varies greatly depending on the reflectivity of the playfield, the size of the playfield, and a whole other slew of variables that will dictate whether you will have a great or an average HDR experience. So just as an example, basketball is one of the best I find in all the sports I've analyzed for HDR for a multitude of factors. First of all, the playfield is highly reflective, so the highlights from the stadium lighting hit it and create a very wide distribution of light, as you can see on the histogram. The playfield is not too large, so it doesn't occupy the whole area of the image. You always see the crowd and things happening at different light levels around it. So it's pretty rich and spectacular from a dynamic range standpoint. But if you take something like soccer, football, the playfield is very, very large. It's not reflective because it's grass, and it's very, very flat. So what happens is our histogram shrink. These kind of images benefit from UHD on the wide color gamut side because the greens and the reds and the blues are very spectacular. But from a strictly dynamic range standpoint, you're not going to get a very outstanding experience because you're using around 3 or 4 stops of latitude. So putting this in a 12 or 14 stops container is not going to create something that isn't there. Another issue we have, especially with lighting during the day outside, is you don't always control where the light and where the shadow is going to be and where it's going to happen versus your playfield. So this here on a low dynamic range, or standard, to be polite, standard dynamic range screen, I can see everything from the action on top to what's in the shadow. Take this, put it at 1000 nit maximum brightness on the screen, and you're going to have no problem to see the top portion, but the lower part for contrast is going to be very dark, very hard to watch. And that's actually where you want people to watch because this is where the action is happening right now. So when this happens, we actually have to tone map down. Even though we captured in HDR, we're going to lower the highlights and we're going to raise the shadow. So we're bringing it back to an SDR image because the main goal is to understand what's happening on the playfield, not to create beautiful images, as this is sport. So even though I captured in HDR, I'm actually going to present an SDR image because of the conditions. Another area is documentaries and nature. This is the area where you're mostly outside and don't control the light. Then the value of HDR as a capture tool, so having wide latitude is tremendous. If anyone can capture in HDR, that's great. For presenting, it really varies depending on the daylight conditions. Is it going to be snowy? Is it going to be cloudy? Is it going to be shiny? And if we have a lot of sunlight, is the sunlight hitting exactly where I want it? So I've worked on an IMAX documentary where we're shooting all outside, and this was for also high dynamic range demo on the home. And basically what we had to do is a lot of scouting to say this location, we need to be there at 2 p.m. because this is where the sun will hit just in the right spot to give us the highlight on our subject of interest and get interesting shadows elsewhere. Then at 4 p.m. we need to be at that location, so on and so forth. So you need to manage light a lot more carefully because of those very bright highlights. It has limited value if you're doing underwater photography, if you're in an environment, for example, a rainforest, which is very cloudy, doesn't have a lot of sun. Well, there's not going to be a lot of latitude in front of the camera. We can't expect that the overall OOTF is going to give us more light on the output if we don't have light on the input. So example of great HDR composition, right at the right time, at the right spot with the sun hitting the glacier, so the highlights are on our subject of interest, a lot of latitude as you can see. This one was shot in SDR, so we see a bit of clipping, which would not happen if we had 14 stops, for example, of latitude with an HDR camera. So these kind of shots are spectacular in HDR. But on the same production, you go on a day where you're shooting underwater or in a cloudy condition, and you see that the histogram is suddenly shrinking significantly. And we went from 10 stops and more of latitude to less than 6. So less latitude in front of the camera, less latitude outside when you present it on the screen at the end. Now let's talk about motion pictures, what I call cinematic series, so all the TV series that are shot like motion pictures. This should be our ideal environment for HDR because we have customized lighting and we can design it and set it for every single occasion. For this to work effectively, we need to remember that the cinema version, even in laser cinema, is going to hit 100, maybe 106 nits on the screen. That's bright, but if you open your laptop in a theater, you're still going to annoy a lot of people. If you take the same thing and present it at home, your highlight is now at 1,000 nits, so it's a lot brighter and creates a lot more contrast on the screen. So that needs to be taken into consideration, because it may look great in a theater, but all of a sudden you take the same content and put it home and you need to apply some tone mapping because it just looks too bright. So a lot of the work I do in consulting is working with creatives. We go on sets and we take the equipment and we actually work with it. And they do traditional lighting, they look at it, and they understand certain things, change the lighting settings. So it's part of an education process for them to understand how the HDR lighting language is different from what they've done before. Typical issues we see, shots that have strong backlights. So for me, for example, the light is right in front of me, so I see people a little bit less. If we have this kind of environment in our production, the bright highlights typically steal the show and I cannot see the characters. Highlights outside the subject of interest, like our train example before, and of course, narrow light distribution. So I've taken just a classic image on YouTube of the good, the bad, and the ugly here. And what you see is masters of light. The Italians were really great masters of light. And what you see is you have a fairly good distribution of light up to the sky that is near clipping at 5 stops above, but it's blue, so it's not so noticeable. And then you have highlights and shadows throughout, and you see that the sun is hitting our character, so we can detach him from the background. So that has a tremendous potential to wow our audience in HDR. But if we take shows that are designed more for a film noir kind of environment, gritty, underground, like an example here where we have a lot of backlight. The backlight is pretty strong. When you present this in HDR, the backlight is basically all you see, and the characters become very hard to perceive. It's not that the shot is not beautiful. It's very beautiful. It's very cinematic. It tells a story. In a theater screen where that highlight is going to be at 100 nits, it's not an issue. In a home environment where that highlight is at 1,000 nit, that's basically all you see on the screen. Another example from cinematic type TV series, when we have those dark and gritty moments, it's kind of challenging to go and push the HDR envelope and show everything on the big screen, because those highlights, once again, are all that you see. So when we go in color grading of those things, we need to bring down the highlights and basically tone map our image to make it more enjoyable. The creatives are usually reticent to raise the light levels in the low area, so we end up lowering the highlights, and it makes it very nice to watch, but not necessarily taking advantage of our HDR screens. Wow, I've been fast. So looking at all those types of contents and with actual Rec 709 values and pumping out the histograms, what I came up to realize is that very different types of content are going to be either a lot better in HDR, not really a difference, or it can actually hinder the experience if you present them with the full latitude at capture. So that means that it's great what we do, and we'll have lots of talks about what we do once we're handed the assets and we have to pump them down, convert, cross-convert, distribute, display. But if we don't have a good merge of technical and creative at the beginning to work with the creatives for them to understand and embrace what HDR does to the image and the power it has to actually blast you, it's going to be difficult to consistently make the most of our technology, and we'll end up with situations where we actually need to do a lot of tone mapping, which still makes nice images, but it doesn't take the full potential of HDR. So I have time for question plenty. That's roughly what I wanted to talk about, if there's any questions.
Hello.
Hello.
Bill Feitner with Colorfront. Two questions. The first one is the million-dollar question. We talk about SDR and HDR, and where is that magic dividing line where SDR ends and HDR begins? And so I'll let you ponder that one. And then the second one is that you've been doing some histogrammatic analysis. What kind of space is that done in? I mean, if we take a histogram of linear sensor data, it's going to show you one thing. If we take one of gamma encoded data, it's going to be something else. And neither one of those are going to be representative as to how we see it.
Absolutely, yeah. So to answer that one first, all the histogram analysis that were done were actually done in Rec. 709 versions of asset, which have a gamma of 2.4 that corresponds to those 10 perceptually equal spaces, so that the code values actually make sense with what we're seeing.
Yeah, but that distribution doesn't really relate to what we perceptually would see on the screen. In other words, it's going to really be biased. And likewise, if we had done it with linear data, it would even be further biased as to what our real visual experience would be in front of the screen. And one would think that that would be the ultimate goal.
Well, the idea here was not to analyze the quality of those images per se, but try to backwards determine what the exposure values were during the time of capture. So when we had live data, I would actually go with a light meter and measure it. I've also checked Rec. 709 versions of things we actually took live measurements. So the idea here is more to see the exposure values and then understanding that if I put my maximum at 1000 nit, where is going to be my baseline in this or that image?
Yeah, I mean, because when we look at these diagrams, and this is something that I think has plagued our industry, especially with HDR, is that we look at the distribution and we see, okay, we have 100 nits, it's right at the beginning. Say if we're looking at a distribution of 0 to 1000 nits, we see 100 nits just making up 1/10 of the scale, or a very small part of the scale, and then we have this big jump to 1000 nits, and quite frankly, what we see on the screen is that you know, it's more of a logarithmic progression, and that really distorts what our visual impact would be. So the bulk of the image up to 100 nits represents a lot of what we see, and then the difference between that and 1000 obviously is not, you know, not linear component or linear
Perceptually right. What we've seen, the thing about the 1000 nit and why I keep bringing it during the presentation is something that we call the high beam effect. And we're doing studies right now, a certain percentage of the screen at 1000 nit, especially on larger size displays, actually create localized contrast. It's very strong for your eye, and you have trouble perceiving your character, especially when they're strongly backlit. So that's something that we're doing research on, and why we link it to, it's not a problem in a theater to have 3 stops over at 100 nits, but when it's at 1000, it does create some
that is
issues.
certainly true, but I mean, if you were to take, if it were offensive, say at 1000 nits, and you brought it down to 500 nits, it would probably still be somewhat reduced, but still offensive because
Yep.
the difference is perceptually very, very little
Yep.
between the two.
It would look spectacular, or it would look great, but it would not be taking full advantage of the HDR envelope, I guess, is the key point here.
And then back to the first question, of which I ask everybody when they talk about SDR and HDR, where does one end, where does the other begin?
And in what sense do you mean that?
Well, we talk about, does SDR end at 100 nits and 101 nits is HDR or, you know?
Perceptually. I tend to look at the images more in terms of exposure values and then transposing them.
Yeah.
And the challenge of low latitude capture. So if you say, yeah, I'm capturing in SDR, and all of a sudden you decide to set a certain environment, and then you're clipping a lot of stuff, which then creates issues in HDR. Good example, I was working on a movie, and the director had a very SDR aesthetic, and everything was strongly backlit, and it was a piece, period piece, and it was all people dressed in antique clothing and stuff. And when they went to do the HDR version, since they had very high latitude in the capture, all of a sudden we could see modern cars running outside the windows.
No,
So.
I
But
think
if you let it blow, and it blows at 1,000 nit, it's not very flattering for you to watch it on the screen.
That's
So.
a big problem with practical lighting, and for HDR is one of the biggest things I think that needs to be dealt with and also previewed. And we found on a number of things is that it's often, you know, let something go several stops over on the practical lighting behind an actor, and it's fine in SDR. When we go to HDR, that dominates the whole picture. But bringing that down a couple of stops in the lighting, when you look at the SDR, hardly makes any difference. So that's a compromise in lighting that benefits both. And hence, I think it's really imperative as we move forward that we're able to preview both SDR and HDR in the field. And I would invite some people to, and yourself, come by our ColorFront booth, and we'll show you some of those things, because I think those are the very problems we're all facing, and thank you for identifying some of them.
Yeah, well, seeing is believing, and yes, I believe that we need to take charge with our creatives and show them the results. So doing this is exactly the right thing to do, I think. Thank you.
Well, thank you.
Thank you. We still have time.
Hi, Chris Seeger with NBC Universal. So in broadcast, in a live linear workflow, we've got a bit of an issue. It's different than a file-based color shading situation.
Yep.
So the shader is going to shade for flesh tones, and let's say we have a bright sunny day. Let's say football players are wearing white jerseys, and it gets super bright in HDR, but you know, we still want to sort of target our focal point, which are the players and their flesh tones. So do we have the tools? Do you have any suggestions on how to control those super bright whites that then get converted to SDR for our main customers? And we, you know, in that situation, we lose our detail on all those white jerseys and any other information that might be on them.
I think the things that need to get developed is using high latitude cameras, but not necessarily using all of that data, and doing intelligent tone mapping to see, okay, I've captured all of that bright white, but I don't want to present it at that level. And that's a bit of what I've been doing with those exposure analysis, is to come to a point where we can work with a manufacturer and have the shader basically on his screen with an HDR image and saying, this is my baseline, and I know I don't want to go more than that many nits on top of it, so that the system analyzes the highlight and tone maps them down automatically, so that you can go and set, depending, oh, now it's in the dark area, so I can just hit the screen and say, this is my new baseline, so now he's going to tone map down everything behind and raise this and make it enjoyable.
So we need a tool that's going to identify those large area brights, allow you to bring them down separate from the rest of the imagery.
Yeah, up to a certain point where it becomes fake, so you have to be careful of the way you do it. But
So,
I don't see any practical alternatives at this point. Just because our highlights are so bright, we actually need to bring them down.
so for the manufacturers that are here who are listening, this is a tool that we need.
Yeah, but we want it at the broadcast control, not in the TV, which is where the issues happen when every single TV manages light differently, and then we're trying to establish a baseline, and I look at 5 models and I have 5 very different experiences. So if we can do it at the CCU level, at the shader level, to be able to do those operations, that would greatly enhance what we can do.
Thank you very much.
Thank you.
Thank you for watching. If you enjoyed this video, please tap the like button and also subscribe to our channel to receive notifications when we add new content. For more information about us, please visit SMPTE.org. We'll see you next time.